आइए हम सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ। एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़, की आवाज़।
Celebrating Azadi Ka Amrit Mahotsav, we bring you a podcast series on STEM popularization, science, technology, engineering, mathematics and medicine, supported and catalyzed by the National Council for Science and Technology Communication, Government of India. This program is produced by Media for Community Foundation. Creative content and technical support is given by Purvasha Banerjee and Shushanto Das.
एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़, की आवाज़, की आवाज़।
Indian Statistical Institute is a public university which is recognized as an institute of national importance. It grew out of the statistical laboratory set up by Prashanta Chandra Mohananobish in Presidency College, Kolkata. Established in 1931, this unique institution of India is one of the oldest institutions focused on statistics. Primary activities of ISI are research and training of statistics, development of theoretical statistics and its applications in various natural and social sciences. In this podcast, we are happy to present Dr. Joydev Chattopadhyay, Professor in Indian Statistical Institute, Kolkata. He is one of the pioneers of eco-epidemiology as a subject. Let's hear from his own voice about this unique study.
So myself, Joydev Chattopadhyay, Professor of Agriculture and Ecological Research Unit of Indian Statistical Institute. By training, I'm a mathematician at school, and I'm mainly working on different issues on ecological issues, epidemiological issues, and eco-epidemiological issues. So if you look to from the mathematical point of view, so mathematical ecology, it has been started with the hands of Lotka and Volterra in the year of 1922. On the other hand, epidemiological modeling was started in the year of 1927 by Cormac McKendick on that year. So these two subjects were already running for a long time. So one issue came that is basically not from our country. It's basically the problem of California. That is, the problem is there is a Salton sea. They are telling it is a sea, but it's basically a lake actually. So there are so many tilapia fish which was originated from Africa, and that there is a avian botulism bacteria. There is a bloom of that particular bacteria, and it affects the gills of the tilapia fish. And as you know, when it is affected by some bacteria with the gills of the fishes, as for example the tilapia, so for void of oxygen, they are coming up to the surface of the water, and it's easy to predate by the pelican birds. As for example, in the year of 1991, in a single day, the 15,000 pelican birds were died. So as you see, this is a big problem, and as you see, this is, it's not, if you want to see this problem from ecological point of view, you can't explain. If you see the problem from the epidemiological issues, you can't explain. So these two subjects or these two, some parameters you'll have to take into account from ecological things, and some parameters you'll have to take into account the epidemiological things. So to address this problem, this was a collaboration work. At the time, I was visiting the University of Po with Professor Joydev. So he's a excellent mathematician. He was died actually in 2007 when we are. I am also there also when he's giving a lecture in Spain in the dais. He died. It's a very sad, of course. So we thought that this issue, how we can explain this issue, and we address this issue, and I'm happy to tell you that, and the Sultanship Authority have taken into account our findings. So we merge the ecology and epidemiology, and we coined the term ecopidemiology in the year of 1999. And if you go to the Google, and you see that even now, many people are working on that particular issue with a term ecopidemiology. So a new field of research has emerged with our hand, myself and Professor Joydev. This is the one part which I'd like to mention actually.
Professor Chattopadhyay speaks on his area of research.
Before that, I just want to say another one part actually, which I think that it will be helpful for the general people actually. So many people know that the plankton, actually it knows the people who are, the school students also knows the plankton. So plankton, what is plankton? For the school student, I can say plankton is the basis of all aquatic food chain, and more than 75% oxygen are coming from that particular species, and it also absorbs half of the carbon dioxide from the Earth's atmosphere. So today I'm going to say one paradox. What is that paradox? That's known as a plankton paradox, and which was pointed out by Hutchinson in the year of 1961. What's the paradox? So if you look to our terrestrial system, there are innumerable number of resources. So many species coexist. On the other hand, if you look to our aquatic system, we do have only 13 to 14 minerals there. For example, sodium, potassium, etc. So if it does not dissolve in the oxygen, that microscopic species cannot take it. So, but more than 45,000 species so far exist of the aquatic system. So we have only 13 or 14 minerals, but more than 45,000 species coexist. So how this large number of species coexist with this seemingly limited variety of resources, that's the paradox. And peoples around the globe, they are trying to solve it in different angles. For example, some peoples are talking about some sort of weather-driven fluctuation. Some peoples are thinking about the competition for the resources, and a very big group from the Netherlands, they are trying to see that problem on that competition for the resources, the main factor for this coexistence of innumerable number of species. But we are working in our region for the last 20 years or so more, in the Digha region. And Digha, as you know, that it's a part of Bay of Bengal, and it's a sea. We are going to the sea for twice in a month, and we are collecting the samples from the sea and coming back to our laboratory. We are seeing that how many plankton species we have, phytoplankton, zooplankton. So we have also identified more than 41 species from that particular region, which is already, the people know that these are the toxic species. They can release the toxic chemicals, and this factor. So our thinking is that as we have identified nearly 41 species from that particular region, the theory came, new theory we have developed, that we call this a toxin-producing phytoplankton may resolve this issue. So we have given another solution which exists throughout the globe, another solution we give, and the people are using and try to thinking about this particular solution from that particular point of view. So these are the two things we are working for the long time. And so as you mentioned that today, what I am going to speak today. So basically now, apart from this, I am one of my collaborators. So myself and Tonoy, we are working mainly two projects now. So one is Smart NLD. It's a non-lethal deterrent. What we are doing? So we are using the advanced sensors to mitigate, as you know, that human-wildlife conflicts in India It's a big problem. So we are trying to solve this problem with using the smart NLD, and we are now in the developing stage, and hopefully it will be started within a month or something. That will be in the field. We are going to implement this very soon. So what we are doing? People are working. If you look to the Australia, the people are working this human-wildlife conflict. They are using some sort of sensors. But here, our government of India also trying to solve this problem, and they are using some sort of what I can say that ANDAS that they are using presently. So ANDAS has some sort of problem is that. So what that instrument basically. So if anyone pass, whether that's a elephant or that's a tiger or it's a small animals, it always gives you the signals of that. But what we are looking, because the conflict is for the elephant, tiger, the human-wildlife conflict. So our NLD things will not take into account that sort of things. They will only capture that images which have the direct wildlife and human conflict of that particular region. So we are trying to develop a smart NLD, and it that also use some sort of patterns of light and sound to deter animals like elephants, tigers, and leopards. So this is the project which we are now taking into account in our part.
Professor Chattopadhyay now focuses on how it is useful for the common person.
I can say that the use of non-lethal deterrents like smart NLD is highly beneficial for common people and India as a whole, particularly in rural areas where human-wildlife conflicts are frequent. These conflicts often lead to the use of lethal measures against wildlife, adversely affecting carnivore population and creating a negative impact on the environment. Implementing NLD methods can help in conserving wildlife while securing the livelihoods of rural communities living in close proximity to wild animals. This approach is essential in preventing losses of crops, livestock, and human lives in shared labors.
We are immensely enriched by his excellent deliberations.